In the constellation Boots, there exists a hole in space, so massive that it could swallow 1,000 Milky Way galaxies and still have room left over. This is not empty space between stars or even between galaxies. This is a region where galaxies themselves simply do not exist. Scientists call it the Boots Void, and its discovery shattered our understanding of how the universe should look. We will journey into this cosmic abyss, explore the few lonely galaxies trapped within its boundaries, and discover how this great nothing forces us to question everything we thought we knew about reality itself. If this journey into the universe's darkest secret intrigues you, hit that like button and subscribe for more cosmic mysteries. Prepare yourselves. We enter the void. Music. In 1977, astronomer Robert Kirshner pointed his telescope toward the constellation Boots and found absolutely nothing. Not the faint glow of distant galaxies, not scattered star clusters, not even cosmic dust. Just emptiness stretching so far that light itself seemed to disappear into the black. Kirshner had stumbled upon something that should not exist according to every model of how the universe works. You have to understand what makes this discovery so disturbing. When we look into deep space, we expect to see galaxies everywhere. They should be scattered across the cosmos like cities viewed from an airplane at night. The universe, we believed, was relatively uniform. Matter should be spread out fairly evenly, with galaxies forming a cosmic web of light stretching in every direction. But this region of space broke all the rules. Picture this. If you could shrink the Milky Way down to the size of a quarter and toss it into this void, you would need to throw 999 more quarters to even begin filling the empty space. The void spans 330 million light-year across. That means light traveling at 670 million f takes 330 million years just to cross from one side to the other. Think of it like finding a perfectly empty parking lot in the middle of Manhattan. Except this parking lot is bigger than Manhattan, bigger than New York State, bigger than the entire continental United States. It is a region of space where matter simply chose not to exist. The discovery sent shock waves through the astronomy community. How could such a massive region contain almost nothing? Where did all the matter go? Did it never form there in the first place? Or was it somehow pushed out by forces we do not understand? Kirshner named his discovery the Boots Void after the constellation where he found it. Other scientists began calling it the Great Nothing or the Cold Spot. As more powerful telescopes turned toward this region, the mystery only deepened. Survey after survey confirmed the impossible. This was not just a gap between galaxies. This was a hole in the very fabric of the universe itself. The void challenged everything astronomers thought they knew about cosmic structure. If the universe formed from tiny fluctuations in density after the Big Bang, how could such a massive region remain so completely empty? What force could be powerful enough to keep galaxies from forming across such an enormous volume of space? As Kirshner continued mapping the void's boundaries, he realized he had found something far stranger than anyone could have imagined. The emptiness was not random. It had structure. It had purpose. And deep within its heart, a handful of galaxies hung in the darkness like lonely islands in an infinite ocean. But these survivor galaxies held secrets that would make the mystery even more terrifying. When astronomers first calculated how many galaxies should exist in the Boots Void, they expected to find around 2,000 bright star-filled systems scattered throughout the region. They found 8. 8 lonely galaxies floating in a space that should house 2,000. Imagine walking into a concert hall designed for 2,000 people and finding only 8 scattered individuals sitting in the darkness. The silence would be deafening. The emptiness would feel wrong at the most fundamental level. These 8 survivor galaxies became known as the Void Galaxies, and they defied every rule about how galaxies should behave. Normal galaxies live in neighborhoods. They cluster together, gravitationally bound in groups and superclusters. They trade matter back and forth, sometimes colliding and merging over billions of years. They exist in a cosmic society where no galaxy truly stands alone. But the void galaxies are different. They are cosmic hermits, isolated beyond anything we have ever observed. The nearest neighbor to any void galaxy is typically 50 million light-years away. For comparison, our closest major galactic neighbor, Andromeda, sits only 2 million light-years from the Milky Way. The void galaxies are 20 times more isolated than we are. This isolation has had profound effects on their development. Without nearby galaxies to interact with, they have evolved in cosmic solitude. Many are surprisingly small and dim, as if the emptiness around them has somehow stunted their growth. They contain fewer heavy elements than galaxies of similar age in normal regions of space. Their star formation rates are unusually low, creating galaxies that seem almost sleepy compared to the bustling star factories we see elsewhere. Scientists call this phenomenon galactic underdensity, but that sterile term cannot capture the true strangeness of what we are observing. These galaxies are not just separated by distance. They are separated by an emptiness so profound that it affects their very nature. They are like children raised in isolation, developing differently than they would in a normal cosmic environment. The mathematical probability of finding such massive underdensity by random chance is less than 1 in a million. The universe should not be able to create such emptiness through normal processes. The Big Bang should have left behind tiny variations in density, but those variations should average out over such large scales. Finding a region this empty is like flipping a coin and getting heads 1,000,000 times in a row. Yet here it exists, challenging our most basic assumptions about cosmic evolution. The void galaxies themselves seem to know something is wrong. Their peculiar properties suggest they are shaped by forces we do not yet understand. Forces that can carve massive holes in the fabric of space itself. The mystery deepens when we examine exactly how these 8 survivors are arranged within their cosmic prison. The 8 galaxies trapped within the Boot's void are not scattered randomly throughout the emptiness. They are arranged in a perfect tube. Picture a massive invisible subway tunnel stretching across 300 million light-years. Now imagine 8 subway stations evenly spaced along that tunnel, each one glowing with the light of billions of stars. This is how the void galaxies are arranged, forming what astronomers call a filament structure through the heart of the great nothing. This arrangement should be impossible. In normal regions of space, galaxies cluster around the densest areas, following the gravitational pull of dark matter. They form webs and sheets and clusters, but always following the underlying structure of matter distribution. Random chance cannot explain why 8 isolated galaxies would line up in such a precise formation. The tube stretches from one edge of the void to the other like a cosmic highway connecting distant shores of normal space. Each galaxy sits approximately 40 million light-years from its nearest neighbor along this invisible line. They are like streetlights on an impossibly long and empty road, marking a path through the darkness. This filament arrangement suggests that the void is not simply empty space. Something must have guided these galaxies into this formation. Some underlying structure invisible to our telescopes must exist within the emptiness. Dark matter perhaps, or some other form of matter we have not yet learned to detect. Scientists have proposed that the 2 represents a fossil from the early universe. During the first few 100 million years after the Big Bang, matter was distributed differently than it is today. Perhaps the void galaxies mark the location of an ancient filament of dark matter that once connected distant regions of space. As the universe expanded and evolved, most matter was pulled away from this region, leaving only this ghostly thread behind. The galaxies themselves show signs of unusual behavior that supports this theory. They are all moving along the same direction as if following an invisible current. Their velocities are synchronized in a way that suggests they are all responding to the same gravitational influence. Yet, we cannot see what is pulling them. Spectroscopic analysis reveals that the void galaxies contain fewer heavy elements than galaxies of similar age in normal regions. This suggests they formed in an environment with less dense matter, supporting the idea that this region has been under time capsules preserving conditions from an earlier epoch of cosmic evolution. The tube structure also explains why the void appears so empty from most viewing angles. If we look at the void from the side, we see it edge on, making it appear as a thin line of galaxies against the emptiness. From most other angles, the galaxies are aligned in such a way that they appear as a single point of light. This cosmic perspective trick makes the void seem even emptier than it actually is. But the true horror of the void becomes apparent when we measure how rapidly this emptiness is growing. The Boots void is not static. It is expanding faster than the universe itself, growing emptier with each passing million years. Imagine a balloon with a small hole that keeps getting bigger. As you inflate the balloon, the hole does not just maintain its size. It grows proportionally larger, consuming more and more of the balloon's surface. The Boots void behaves similarly, but instead of consuming rubber, it is consuming space where galaxies should exist. Measurements show that the void is expanding at a rate roughly 10% faster than the cosmic expansion caused by dark energy. This might seem like a small difference, but over cosmic timescales, it represents a fundamental departure from how space should behave. While normal regions of the universe expand due to dark energy, the void seems to be actively repelling matter, pushing galaxies away from its boundaries. This accelerated expansion creates what scientists call void instability. Once a region becomes underdense, it becomes easier for matter to flow out of it rather than into it. Gravity, which normally pulls matter together, works in reverse at these scales. Instead of attracting nearby galaxies, the void's emptiness creates a gravitational gradient that pushes matter toward denser regions. Think of it like water flowing downhill. Normally, galaxies are attracted to areas of high matter density, like water flowing toward the bottom of a valley. But in the void, the emptiness creates an upward slope. Matter naturally flows away from the void toward regions where other galaxies already exist. This creates a feedback loop where emptiness breeds more emptiness. The mathematical models are disturbing. If current expansion rates continue, the Boots void will double in size within the next 5 billion years. By the time our sun burns out, this region of space will be twice as empty as it is today. The 8 survivor galaxies will be pushed further apart, their isolation becoming even more profound. But the expansion rate suggests something even more unsettling. The void is not just growing through normal cosmic expansion. Something is actively pushing matter away from this region. Dark energy, which causes the accelerated expansion of the entire universe, seems to be concentrated more heavily within the void. This creates a kind of cosmic vacuum cleaner, effectively sucking matter density out of the region. Some theoretical physicists propose that we are witnessing the birth of a cosmic bubble of false vacuum. In this scenario, the laws of physics themselves might be different within the void. The vacuum state of space might be unstable, causing it to expand exponentially and push all matter toward the boundaries. If this theory is correct, the void represents a glimpse of what the entire universe might look like in the far future. The expansion also affects how we observe the void from Earth. Light from the few galaxies within the region is being redshifted more than expected, stretched toward longer wavelengths by the unusual expansion rate. This makes the void galaxies appear more distant and dimmer than they actually are. As the emptiness grows, it begins to affect the cosmic neighborhoods surrounding it. Around the edges of the Boots void, galaxies huddle together in unusually dense walls as if fleeing from the emptiness within. These boundary regions contain 3 times more galaxies than normal areas of space. Imagine a crowd of people pressed against the walls of a room, all trying to stay as far as possible from something terrifying in the center. The galaxies surrounding the void behave exactly this way, clustering into dense filaments and sheets that form a kind of cosmic containment barrier. Scientists call these structures void walls, and they represent one of the most extreme examples of large-scale structure in the known universe. The walls stretch for hundreds of millions of light years, forming massive curtains of galaxies that separate the emptiness from normal space. Some individual wall segments contain more than 10,000 galaxies packed into regions that would normally hold only 3,000. The density gradient is so sharp that you can actually see where normal space ends and the void begins. It is like standing at the edge of an ocean and watching where the water meets an empty beach. The transition happens over a relatively narrow zone, perhaps 20 million light-year wide. On one side, galaxies crowd together in normal cosmic abundance. On the other side, there is almost nothing. This sharp boundary violates our understanding of how matter should be distributed in the universe. Density variations should be smooth and gradual, following the gentle curves of gravitational influence. Instead, the void creates a cliff-like drop-off in galaxy density that suggests some violent process carved this hole in space. The void walls themselves show signs of unusual behavior. Galaxies within the walls are moving faster than expected, as if something is actively pushing them away from the void's interior. Their peculiar motions suggest that a repulsive force operates within the emptiness, creating what physicists call a negative pressure gradient. Computer simulations struggle to reproduce these wall structures through normal gravitational processes.